Hi everyone, today we're going to be solving Edexcel IGCSE Chemistry for CHO January 2015. This is paper 1C. In this video, we're going to be solving the whole paper. This question is about elements hydrogen and oxygen. The circles in the diagram represents molecules of hydrogen. Place a cross in the box under the diagram that represent hydrogen gas. The gas molecules will be far apart. The diagram below shows two different atoms of hydrogen. We can see one of the hydrogen has only a proton, the other one has a proton and a neutron. So Y is a isotope. The particle furthest from the center of each atom is the electron. The particle present in atom Y but not in atom X. We can see that in atom Y there is a neutron and atom X doesn't have it. Both atoms are neutral because they have the same number of protons and electrons. Different atoms of oxygen can be represented as oxygen with O16 and oxygen with O18. Select word or phrases from the box to complete the sentences about these atoms of oxygen. These atoms of oxygen are called isotopes because their atomic numbers are the same but their neutron numbers are different or mass number are different. This question is about the separation of mixtures. The table shows some methods that are used to separate mixtures. Place a tick in one box in each row of the table to show the best method of separation of each mixture. Red ink from a mixture of colored inks. Definitely chromatography will be the best technique for this. Ethanol from a mixture of ethanol and water. Because ethanol and water has difference in boiling point, ethanol has a boiling point of 78 degrees Celsius and water has a boiling point of 100 degrees Celsius, so we can use fractional distillation. Sand from a mixture of sand and water. So for this process, because sand is a solid, we can use filtration. Water from copper sulfate solution. Because copper sulfate is a salt, so we can separate the water by using simple distillation. Which of the mixture PQRS contain an undissolved solid? So we can see an undissolved solid to be present in sand, so R. Pure dry crystals of magnesium nitrate can be obtained from magnesium nitrate solution by crystallization. These steps describe the method, but the steps are in wrong order. Allow the solution to cool to room temperature. Heat the solution to evaporate some of the water. Pour the mixture of crystals in solution through filter paper. Put the crystals in a warm place to dry. Dip a glass rod into the solution in the crystals formed. Write a letter for each of the box to show the correct order. So the first step will be heat the solution to evaporate some of the water. Then dip a glass rod into the solution to see if the crystals are forming. After that, we'll have to allow the solution to cool to room temperature. And then we will pour the mixture of crystals solution through a filter paper so that we can collect the crystals. Then we are going to put the crystals in a warm place to dry. This question is about test for some elements and compounds. What is the test for hydrogen? To test for hydrogen, we need a lighted splint. So the lit splint will burn with a pop sound or a squeaky pop will be heard. The diagram shows hydrogen burning in air and how some of the gases passing through the apparatus are collected and tested. So hydrogen burning, the gas is then collected. So the water vapor from the hydrogen burning will condense here. If there was any CO2 that was produced, it should be confirmed by the lime water and then the air is going towards the pump. A colorless liquid collects in the U-shaped tube and the lime water turns cloudy very slowly. Describe a chemical test to show the colorless liquid contains water. The chemical test for water is actually anhydrous copper sulfate or anhydrous cobalt chloride paper. Now, if it is anhydrous copper sulfate, then adding the water will turn it blue. If it is anhydrous cobalt chloride, then adding water will turn it pink. Describe a physical test to show the colorless liquid is pure water. The physical test for pure water would be boiling point. If we measure the boiling point or the freezing point, water will boil at 100 degrees Celsius or it will freeze at 0 degrees Celsius. A reaction involving carbon dioxide causes the cloudiness in the lime water. Place a cross in two boxes to show the correct statements about this reaction. Carbon dioxide forms when hydrogen burns. Well, when hydrogen burns, then water is only formed. Carbon dioxide from the air reacts to cause the cloudiness. Yes, CO2 is present in air in very small concentration, 0.004. So it can react to make the solution cloudy. The cloudiness is caused by the formation of calcium hydroxide. The calcium hydroxide dioxide is colorless in this case. The cloudiness is caused by the formation of white precipitate. Exactly. So the white precipitate is actually calcium carbonate. The reaction in the lime water is an example of oxidation. No, it's not an example of oxidation. It's actually a neutralization or a precipitation. A student draws this diagram to show how he plans to prepare and collect oxygen gas in a laboratory. We have manganese peroxide and hydrogen peroxide. We have oxygen that is collected under water. So the delivery tube is dipped underwater, and as the oxygen goes up, the oxygen displaces the water and the water level comes down. The student makes a mistake in the labeling. He also misses out a piece of apparatus. State the mistake in the labeling of the diagram. So in terms of labeling, the reactant is labeled in the wrong way around. For example, the manganese oxide is the solid and the liquid is the hydrogen peroxide. Identify the piece of apparatus missing from the diagram. So from the diagram, we can see that the rubber bung is missing. State why this piece of apparatus is necessary. This piece of apparatus prevents the oxygen, which is a gas, from escaping. The student adds the missing piece of apparatus, then collects some oxygen gas. This oxygen gas contains water vapor. Suggest how he could alter the apparatus so that he collected dry oxygen gas. The student could use a gas syringe instead of using the displacement of air. The student could use a gas syringe instead of using displacement of water. Balance the equation for the reaction used in this preparation of oxygen. So when hydrogen peroxide is reacted, it produces water and oxygen. So 2H2O2 produces 2H2O and 1O2. The manganese peroxide acts as a catalyst. What is meant by the term catalyst? A catalyst is a substance that increases the rate of reaction but remains chemically unchanged at the end of the reaction. The diagram shows the reaction profile for the decomposition of hydrogen peroxide without a catalyst. We can see hydrogen peroxide, it has an activation energy barrier, and then once it goes through the activation energy barrier, it turns into water and oxygen. Label the diagram to indicate the activation energy EA for this reaction. On the diagram, draw a curve to represent the reaction profile for the same reaction when a catalyst is used. So when we use a catalyst provides an alternative reaction pathway. That means a lower activation energy will be observed. This question is about aluminium sulfate, a soluble salt with many uses. One type of aluminium sulfate has the formula Al2SO4 3.16H2O solid. How many different elements are shown in this formula? So we can see aluminium, sulfur, oxygen, hydrogen. So a total of 4 types. The water in this formula shows that this type of aluminium sulfate is hydrated. Water represented with a dot is water of hydration. Some types of fire extinguisher use a reaction between aluminium sulfate and sodium hydrogen carbonate. So we can see aluminium sulfate with sodium hydrogen carbonate producing aluminium hydroxide, sodium sulfate, and carbon dioxide. State the name of the two metal containing products for this reaction. So the answer will be aluminium hydroxide and sodium sulfate. Carbon dioxide is used in some fire extinguisher. Explain why carbon dioxide is effective at extinguishing fires. Carbon dioxide blankets the fuel or the fire. Because carbon dioxide is heavy, it sinks onto the fuel or the fire. Thereby, it prevents oxygen from reaching the fire. Gardeners can use aluminium sulfate to alter the pH of soil. The reaction that occurs can be represented as aluminium sulfate with water produces aluminium hydroxide and sulfuric acid. Aluminium hydroxide contains hydroxide ion and sulfuric acid contains hydrogen ion. Suggest with the reference to the state symbol why this reaction makes the soil more acidic. Aluminium hydroxide is insoluble, so its ions are not free. Even though it produces hydroxide ion, they are not free. Whereas H2SO4 produces a solution and releases H plus ions into the solution, which makes the soil acidic. The pH of the soil in a garden is 7.5. A gardener adds up some aluminium sulfate to the soil to alter its pH. which is the most likely pH of the soil after the reaction occurs. So the most likely pH is going to be 5.5 because 9.5 and 13.5 are alkaline, whereas 1.5 is too acidic. A teacher uses this apparatus to show the reaction between ammonium gas and hydrogen chloride gas to form ammonium chloride. Cotton wool soaked in concentrated ammonia solution, and on the other side we have cotton wool concentrate soaked in concentrated hydrochloric acid. Concentrated ammonia solution gives off ammonia gas. Concentrated hydrochloric acid gives off hydrogen chloride gas. The reaction between gases can be represented by this equation. Ammonia gas reacting with hydrogen chloride gas to produce ammonium chloride solid. The diagram below shows the apparatus after a few minutes. We can see a white solid is produced, which is closer to HCl gas, HCl, hydrochloric acid, which process occurs when the gas particles move along the tube. The gas particles moves along the tube due to diffusion. Explain how the diagrams show which gas moves more quickly during the experiment. Ammonia moves quickly because the white solid is closer to the HCl end and it is farther from the ammonia end. The teacher tests a sample of ammonium chloride solution. She uses this method to show the sample contains ammonium ions. Add solution X, warm the mixture, test the gas given off with a damp litmus paper. Suggest the identity of the solution X, the identity of the gas given off, and the final color of the litmus paper. So, in order to test, since we have an ammonium salt, we can use sodium hydroxide, and the gas that will be given off will be ammonia. And the final color of the litmus paper will be blue. So we must take a red litmus paper, which will then turn blue. She uses this method to show that the sample contains chloride ion. Add dilute nitric acid, add a solution Y, see if a white precipitate forms. Why does she add dilute nitric acid? She adds dilute nitric acid to remove any carbonate ions or sulfide ions because they will interfere with the precipitate that is formed. Suggest the identities of solution Y and white precipitate. So, to test for chloride ion, the solution Y should be silver nitrate and the white precipitate will be silver chloride. Guys, just as an added bonus, for those who didn't understand why we added the dilute nitric acid, if there were any carbonate or sulfide ion present, then the carbonate and sulfide ion would have given a white precipitate with silver nitrate solution, and that would interfere with the original experiment of testing the chloride ions. Because, for example, sodium carbonate is soluble, potassium carbonate is also soluble. So imagine putting silver nitrate on that, and then immediately you're going to get white precipitate, which will confuse you thinking that it is chloride. However, the ions are carbonate. The alkanes are homologous series of hydrocarbons obtained from the fractions in the crude oil. Describe how crude oil is separated into fractions in industry. Crude oil is separated in the industry by using fractional distillation. So to do the fractional distillation, the crude oil is heated and it is heated to a very high temperature, for example, like 500 degrees Celsius, and then it is passed into the fractionating column or fractionating tower. The fractionating tower is cooler at the top, but it is hot at the bottom. So there is a temperature gradient difference. The fraction condenses at different heights and they condense due to their differences in boiling point. State the general formula of the alkanes. So general formula of alkanes is CnH2n+. State two characteristics other than having the same general formula of the members of homologous series. Members of homologous series have similar chemical properties. They have gradual change or gradual increase or decrease in physical properties. They have the same functional group and the members only differs by CH2. Propane is an alkane and it is used as a fuel. Balance the chemical equation for the complete combustion of propane. C3H8 is burned in presence of oxygen to produce 3 CO2 because there are 3 carbons. And then since there is 8 hydrogen, it will produce 4 H2O. Now we need to count the number of oxygen on the right hand side. 3 times 2 plus 4. So 10. We can put a 5 O2, 5 times 2, 10 oxygen in the left hand side. Incomplete combustion of propane leads to the formation of poisonous gas. Identify this gas. So the poisonous gas is carbon monoxide. Explain why this gas is poisonous. Carbon monoxide reduces the capacity of the blood to carry oxygen because it binds with hemoglobin irreversibly. During the combustion of propane at high temperatures, gases represented by the formula NOx can form. Which two elements combine to form this gas? So we can see nitrogen and oxygen. These two elements combines. The alkane C5H12 has three isomers. The displayed formula of one of the isomer is draw the displayed formula of the other two isomers. So when we are given a molecule like C5H12, we can draw two isomers. One of the isomers, since we can see that the branching is already done, the maximum amount of branching. So first of all, we can think of a straight chain. The second one that we can do is we can do 4 carbons in a row with one methyl group at the end. Methane is used in many countries as a fuel in houses. It has no smell, no substances are mixed with it to allow any leaks to be identified. One of these substances is compound X, which has the composition by mass. Use this information to calculate the empirical formula of X. To calculate the empirical formula, first of all, we'll have to divide the percentage with their relative atomic mass. Then we will find out their simplest ratio. Once we find out their simplest ratio, then we will be able to find out the empirical formula of that particular chemical, H11S1. The relative formula mass of X is 90. What is the molecular formula of X? To do this particular math, first of all, we're going to find out the MR of empirical formula. Then we are going to compare the relative formula mass and the empirical formula in terms of ratio. And then we will be able to find out the molecular formula. Since the relative formula mass and the molecular formula mass is the same, empirical formula mass and the relative formula mass is the same, so the molecular formula will be the same. Ethane is used as a starting material to the manufacture of addition polymers. It is first cracked to form ethene. Identify the fuels that also form in this reaction. So from ethane, we are producing ethene. That means we have to produce one more hydrogen molecule. Ethane is described as saturated. What feature of an ethane molecule is responsible for this description? Only single bonds between carbon atoms represent that this is a saturated molecule. Bromine water can be used to show that it's a hydrocarbon, that a hydrocarbon is ethene rather than ethane. Complete the equation to show the displayed formula of the product of the reaction between ethene and bromine. So we can see ethene reacting with bromine, so it will produce 1,2-dibromoethane. Which is the correct statement about this test? The color of the ethene is brown? No. The product of the reaction is white precipitate? No. The product of the reaction is colorless? Yes. Final one, the test involves substitution reaction? No. The test involves addition reaction. Alkenes can be polymerized. Part of the structure of polyethene can be represented as, this structure shows the atoms coming from two molecules of ethene. Draw the part of the structure of polypropene that shows the atoms coming from two molecules of propene. So to do this particular polymer, we can think of the CC double bond first and draw the remainder of the molecule by keeping that in mind. Then we are going to open this particular carbon-carbon double bond and give it two hands in two sides. Then we're going to draw the second set of molecule just right next to it. The repeat unit of another addition polymer can be represented as follows. Draw the structure of the monomer used to make this polymer. To make the monomer of addition polymerization, we will break the two hands that it has on the two sides and we will establish a carbon-carbon double bond. The disposal of most addition polymer is a problem because they do not biodegrade. What is meant by the term biodegrade? A biodegradable polymer is a polymer that breaks down or decomposes in the nature by bacterial or microorganism actions. Identify the property that prevents addition polymer from easily biodegrading. Addition polymers are very unreactive, so they do not interact with bacteria or microorganism enzymes. This question is about elements in group 1 of the periodic table. Which statement is correct about lithium? The first statement is lithium is a non-metal. We know that lithium is a metal. Lithium forms a sulfate with the formula LiSO4. Lithium is a group 1 metal, so it will produce Li2SO4. Lithium reacts with water to form an alkali. So this is a correct statement. Lithium and potassium have similar chemical properties because they're atoms. Now, lithium and potassium belongs to the same group, so they have same number of outer shell electrons. Small pieces of lithium and potassium are added to the separate large troughs of water. State one observation that would be similar for each element and one that would be different for each element. In terms of similarity, both will do fizzing, meaning that they will produce bubbles. However, the dissimilarities will be the potassium will, spark and explode. It will form a ball of fire, whereas the lithium will be reacting slowly. Suggest a formula of the compound formed when potassium reacts with oxygen and when potassium reacts with chlorine. So when potassium reacts with oxygen, the formula will be K2O, potassium oxide. And when it reacts with chlorine, it will be potassium chloride, so KCl. Complete the equation for the reaction between rubidium and water. Rubidium and water reacts in a very similar way that of potassium. So rubidium is a solid, reacts with liquid water, produces aqueous, and produces hydrogen gas. The table shows the information about the isotopes in a sample of rubidium. Use the information for the table to calculate relative atomic mass for the sample of the rubidium. Our answer must be given in one decimal place. So to find out, what we're going to do is we're going to take the mass number, and then we will multiply with their percentage for both cases. And then we will divide it by 100 to get the average relative atomic mass. This question is about the insoluble salt lead to bromide. A student uses the precipitation method to prepare lead to bromide. The equation for the reaction, she uses lead nitrate reacting with sodium bromide to produce lead bromide and sodium nitrate aqueous. Describe how she could use solutions of lead to nitrate and sodium bromide to obtain a pure dry sample of lead to bromide. The student can react the two solutions together. The student then can stir the solution, which will produce the lead bromide solid. Since all other reactant and product are aqueous, so the solid can then be filtered off by using filter paper, and then it can be washed using water to remove any surface contaminants. After that, it can be left in the filter paper in an oven for drying. The student's teacher uses the apparatus to electrolyze a pure sample of molten lead to bromide. So we can see a power source, a lamp to indicate that the electrolysis is going on, and molten lead to bromide in a crucible. Heat is provided to keep the lead to bromide molten. The student records this observation. A small blob of silvery liquid appears at one electrode. A brown substance forms at other electrode. So this is the lead metal produced. The brown substance is bromine vapor. The lamp stops working soon after the teacher stops heating the lead to bromide. The lamp stops working because once the teacher stops heating the lead to bromide, it solidifies, and solid lead to bromide does not have any free ions to conduct electricity, which is the correct statement about this electrolysis. The products are both elements. The brown substance is bromine, not bromide. The silvery liquid forms at the negative electrode, not the positive electrode. The silvery liquid is not molten lead to bromide. It is lead. The student writes the half equation to show the reaction in which the brown substance forms 2Br minus plus 2 electron produces 2Br. This is a wrong reaction, wrong equation. Identify two mistakes in her half equation. One of the mistakes is she has added 2 electron, which must be taken out, and the other one is bromine is diatomic. Explain why the lamp stops working after the teacher stops heating the lead to bromide. So, when the teacher stopped heating, the ions which were free, they stopped moving, and thereby they were unable to conduct electricity. A student uses the neutralization method to make a sample of the soluble salt sodium sulfate. Sodium hydroxide reacts with sulfuric acid to produce sodium sulfate and water. He does a titration using these steps to find the ratio of the volumes of reactants needed. Add 25 cm³ of solution to dilute sodium hydroxide solution to a conical flask. Add a few drops of phenolphthalein indicator to the conical flask. Add dilute sulfuric acid from a burette until the indicator just changes color. Repeat the experiment until until concordant results are obtained. Which piece of apparatus should the student use to add the sodium hydroxide solution? Because the student is using a fixed volume of sodium hydroxide and it needs to be measured accurately, so the student can use a pipette. What color change would the student see when he neutralizes the sodium hydroxide solution? The color before the solution would be pink. Before the neutralization would be pink because phenolphthalein gives a pink color in alkaline solution. But after neutralization, the color will be colorless because phenolphthalein is colorless in acidic solution or neutral solution. The diagram shows butyrate readings in one experiment before and after the adding of the acid. So we can see butyrate reading before the adding of the acid 1.123 1.4 cm cube. Butyrate reading after the adding of the acid, we can see 23.15. So the volume of acid that is added. So we will subtract 1.4 from 23.15 and the answer will be 21.75. The student repeats the experiment and records this result. Now titration result to be used. We can use the titration results, those that are concordant to 0.1 cm cube, meaning the result must be as close as 0.1 cm cube. So these two results can be used for further calculation. The average mean volume of acid added should be calculated using only concordant results, those that differ from each other by 0.2 cm cube or less. So 0.2 cm cube is also acceptable. Identify the concordant result by pressing tick. We have done it. Use your ticked result to calculate average volume. The student uses 200 cm cube of sodium hydroxide solution of concentration 0.3 mol per cm cube to prepare the sample of sodium sulfate solution. Calculate the amount in moles of sodium hydroxide in the solution. So we have to find out the number of moles, and the number of moles can be found out in this formula. Number of moles of sodium hydroxide is equals to volume into concentration. Then 0.3, which is the concentration in mol per dm cube, multiplied by 200. However, the 200 is given in cm cube, so it will be divided by 1000 to make it into dm cube, and the answer will be 0.06 moles. Calculate the amount in moles of H2SO4 needed to neutralize this amount of sodium hydroxide. Since the molar ratio is 2:1 between sodium hydroxide and sulfuric acid, so the number of moles of sulfuric acid will be 0.06 divided by 2, which is equals to 0.03. Then we will multiply. Calculate the mass in grams of this amount of H2SO4. So MR of H2SO4 is 98, and then to find out the mass, we will use the formula mass is equals to number of mole multiplied by molar mass. A student investigates a rate of reaction between marble chips, calcium carbonate, and dilute hydrochloric acid. She is given a bottle containing hydrochloric acid label 100%. She uses this method to find out how changing the concentration of the acid affects the rate of reaction. Add some marble chips to the conical flask, pour 50 cm cube of dilute hydrochloric acid into the flask, place the flask on a balance, and start a timer. Record the time taken for the mass of the flask and content to decrease by 1 gram. Repeat the experiment using different concentration of hydrochloric acid. Suggest 2 features of the marble chips that the student should keep the same to ensure that the results are valid and it is a fair test. We know that the amount or the mass of the marble chips must be similar, and also the size of the marble chips must be similar, because if smaller size is used, then rate of reaction will be faster. Why does the mass of the flask and contents decrease during the experiment? The reaction produces carbon dioxide, which is a gas, and thereby it escapes, thus it decreases the mass. The student should have put some cotton wool in the neck of the conical flask after placing the flask on the balance. How would this improve the accuracy of the results? The cotton wool prevents the loss of acid by spray, or you can say the spitting of the liquid that occurs when marble reacts with acid. The graph shows the student result for the decrease in the mass of flask and the content by 1 gram, time in seconds, and concentration of acid. Use the graph to find the time taken for the loss of 1 gram of mass from the flask when the concentration of acid is 50%. Show on the graph how you obtained your answer. So when they say show on the graph, we must extrapolate. So the concentration of acid is 50%. We will draw a line and then we will extrapolate to find out the time, which is 210 seconds. One of the points on the graph is anomalous. What could have caused the anomalous result? We can see that this, for the given concentration, the student has recorded a much higher time. So the loss of mass could have been greater than 1 gram. The results of each experiment can be used to calculate the rate of reaction using the expression rate of reaction in grams per second, 1 gram, time to lose 1 gram in seconds. Calculate the rate of reaction when the concentration of acid is 50%. So rate is equals to 1 divided by the time taken was 210 seconds, 0.00476. Three significant figure answer. If the student is given a bottle of hydrochloric acid with a concentration different from that used in previous experiment, she repeats the investigation using different concentration of hydrochloric acid. She calculates the rate of reaction for each experiment. So the rate of reaction in milligrams per second and concentration of acid. Plot the results on the grid and draw a straight line of best fit. The rate of reaction increases as the concentration of the acid increases. Explain this relationship in terms of particles. At higher concentration, there are more particles in a given volume, which means there will be more number of collisions between the reactant particles, and this will lead to a faster rate of reaction per unit time. Guys, that's all for this particular question paper. Thank you for watching this particular video. Guys, see you in the next video.